Over 1 year ago, I made a comprehensive web page with all the details of the 8-bit TTL computer I built. I also posted a small YouTube video to show it running. It seems quite a few people have used this information for building their own TTL computer, and I regularly receive emails with questions about the build and operating instructions on this web page. On this web page, I also provide details on the instruction set, show the logisim emulator, and the Windows emulator, which runs up to 0.5 MHz. I also provided all the schematics, which are all publicly available on ECEDA. And I provided the download with all the documentation, the code and the tools used. In this video, I want to show the casing I built around it and show you how it operates. For the casing, I did not really change anything on the original computer, except adding small switches to enable and disable all blinking lights on the PCBs, and solder connectors on them to break out all those blinking lights and switches to the front panel. It runs stable from 0 to 220 kHz. And it consumes around 250 milliamps. So, let's power it on. I also enable the internal Arduino, which I use to program memory from a PC. When I reset the Arduino, the list light shows it's listing through the memory, and when we are at memory location 0, the program light turns on to show it writing the default primes program to memory. When that's finished, the computer starts running the program. As you can see, we can change the clock speed at any time while running a program. When I turn off the Arduino, we can use the input register. In the case of the primes program, we can specify how many times it should run. Let's put in 2 times and restart the program. For the clock, we can use an external clock or change the internal clock from 1 to 1000 Hz in low, or from 1 kHz to 220 kHz in high. Or use manual clocking to debug our program. With a terminal application, we can dump the memory to a PC. Sorry for my arm being in the way, just increasing the clock speed here. Let's look at some code. This is the primes program I wrote that got automatically loaded at the start. And here you see a very simple counter program. Let's put in the no-op instructions and run it through the compiler I made. And we'll copy the hex bytes to the clipboard. While holding reset, in the terminal program we press P to start programming and paste in the bytes. When we let go of reset, we start writing from memory location 0. Let's pump up the clock speed a bit here. When done, we press P in the terminal again to stop programming and reset the computer to start the program. Let's see if we can change the program to increment by 2. In the code, we see the increment is stored in memory location 2. Let's change this on the computer itself by turning on list mode and walk through the bytes in manual clock mode. Until we are at memory location 2. Now we turn on prog, set a 2 in the input register and advance the clock. And if we run the program now, we see the output is incremented in steps of 2. On the front panel, we can switch the output display between hex and decimal, and between positive and 2 complement number display. We can also turn off or on all the blinking lights. Let's switch to higher clock speeds of 1 kHz to 220 kHz. And run the program again. With 2 complements, and hex output. That's it for now.